Hi, in this video we're going to talk a little bit about the technology of heat pumps and the things you need to know in order to get started. First, I'd like to introduce a couple of concepts. Your home heat load, that's the amount of heat that your home needs to keep warm as a function of the outdoor temperature. And as it gets colder, more heat leaks out of the windows and walls and ceilings, and you need a heating system designed to keep your home warm at the coldest outdoor temperature, which typically here is 0 degrees Fahrenheit or a little below. The heating system capacity for a fossil fuel system is constant. The more you burn, the more heat it produces. And as it gets colder, more heat leaks out of the windows and walls and ceilings, and you need a heating system designed to keep your home warm at the coldest outdoor temperature, which typically here is 0 degrees Fahrenheit or a little below. The heating system capacity for a fossil fuel system is constant. The more you burn, the more heat it produces. Whereas an air source heat pump can extract a little bit less heat out of the air the colder it gets, and so the capacity may fall a little bit as it gets colder. That's why for most systems there will be supplemental heat, and that can be provided either by electric resistance that you install at the same time for those coldest days, or you can keep your old heating system and have it kick in below a certain outdoor temperature. In general, the thermostats may make that transition seamlessly. A contractor can estimate your home's heat load using a standard calculation and design a system with the capacity to meet that load at the low outdoor temperatures. So how about for air source heat pumps, Bob?
Well, thank you, Brad. So in this first figure, we're showing how a furnace or a boiler, a conventional furnace or boiler, might be sized to meet the needs of your home. And so the thing that's interesting about a furnace or a boiler is that it can put out roughly the same amount of heat regardless of the outdoor temperature. And then the red line in this figure illustrates that capacity. But your home heating capacity actually varies as it gets colder. You need more heat for your home. That's illustrated by the dashed green line in this figure. So what a contractor does is he sizes the furnace or boiler to match the worst home heating load you might need at the design condition. Typically that might be around 0 degrees Fahrenheit. And if your temperature goes below that for a couple of days in the year, your furnace or boiler will still provide heat, although maybe not quite at the temperature you'd like. But you'll still keep your home fairly warm. Now, for a heat pump, this situation is quite different in terms of what the contractor needs to do. In the second slide, we see the differences for an air source heat pump. In this slide, you can see the blue line represents the heating capacity of a heat pump. Instead of, as a furnace, having a steady capacity as the outdoor temperature drops, a heat pump will actually drop off in capacity as the outdoor temperature gets colder. And this is important in terms of sizing the heat pump for obvious reasons. So in this figure, you can see that the green home heating load line crosses the air source heat pump capacity line at a temperature that's well above the design temperature. What that effectively means is at temperatures below that 10 to 15 degrees Fahrenheit in this case, you will need some kind of supplemental heating system to assist the heat pump in heating the home. Now there's two ways that can be done. You can leave in place your existing fossil fuel heating system, or you can use electric resistance backup. In this next slide, we'll show a couple of examples of air source heat pumps. There's really two varieties, as we introduced in the introductory video. The first is a ductless heat pump, and in this figure you can see that there is an outdoor unit shown outside the home. It's mounted on a platform to keep it above the snow. And there's also at least one or more indoor units that are mounted typically on the walls, although they can be recessed into ceiling panels or mounted on the floor as well. What's unique about ductless systems is, as the name implies, they do not require any ductwork in your home to operate. This indoor unit and the outdoor units are connected via some copper tubing that circulates refrigerant to and from the outdoor and indoor units. On the other hand, as shown in these photos for a central ducted heat pump, it looks a little bit more like your traditional air conditioning system. You have an outdoor unit mounted near your home, and indoors you have a conventional air handling unit which contains the indoor portion of the heat pump and also typically your supplemental heating system, whether that's electric resistance or a furnace. So how do you decide which type of heat pump would be best for your home, a central ducted heat pump or a ductless heat pump? A lot of the answer to that question comes from how your home is configured today. If you have ductwork in your home today, you might want to consider reusing that ductwork with a central ducted system. And there are some caveats though. The ductwork needs to be sized so that it can handle air conditioning. Many older homes have ductwork that's too small to accommodate air conditioning. Also, the ductwork has to be in good condition, well sealed, well insulated, and suitable for a central ducted system. Your contractor can tell you whether your current ductwork system is suitable for a heat pump or whether you need to do some renovations to make it suitable. On the other hand, if your home does not have ductwork, then a ductless system is your only option for going to an air source heat pump. And that would be a situation where you have a boiler or you have baseboard electric heat in your home. And it's a great way, by the way, to get air conditioning in a home that cannot otherwise accommodate it. But there are reasons why you might want to use a ductless system even if you have ductwork in your home. As I pointed out, the ductwork in your home may not be sized properly. Also, if it's difficult to seal or insulate the ductwork well, you'll want to go with a ductless heat pump. So that's a brief summary of air source heat pumps. I'd like to now turn it over to John to talk about ground source heat pumps.
Thanks, Bob. Geothermal heat pumps are a slightly different animal. They're a deeper commitment towards the technology. It's a little more expensive, and it's a slightly different approach. The main difference is rather than trying to extract energy from air that's anywhere from 10 below zero up to 100 degrees, we're just going to try and extract energy from the ground, which is at a relatively steady 50 to 60 degrees. And what that does is allow the engineers creating the systems to make everything much more efficient. There are three components to a geothermal system. There's the well, magic black box that goes inside the house, and your distribution system. Most wells in this area are closed-loop vertical wells that go down about 400 feet, one or two per house. And they feed the magic black box inside, which is going to increase the water temperature to 120 degrees if you have a hot air system and 150 degrees if you have a forced out water system. The challenge is matching up to your existing distribution system. Oftentimes you can just connect directly to your hot air system. Oftentimes with your hot water you just connect into that. Where it probably doesn't make much sense is if you have a central steam system, it wouldn't make sense to do that. The good news is with geothermal heating systems and cooling systems, the technology has improved dramatically in the last 5 to 10 years on two fronts. One is the computer operating system that allows everything to run, and the other is with variable speed pumping that has really maximized the performance of the systems. Let's go ahead and move into heat pumps for domestic hot water systems. Bob, could you walk us through that, please?
Thank you, John. As this slide illustrates, heat pump water heaters are basically an electric water heater that has a heat pump attached to it. Heat pump water heaters are becoming more and more popular in recent years. They are actually electric water heaters, but they're much more energy efficient. As this slide illustrates, a heat pump water heater has a conventional electric tank beneath it, but mounted on top is a heat pump that extracts heat from the surrounding air and pumps that heat into the water. While heat pump water heaters are very economical in most installations, there are some things you should consider before purchasing a heat pump water heater. First of all, you should understand that a heat pump water heater will cool your basement or your utility closet, and that may be a consideration if you occupy that space. Also, because it cools your home a little bit in the wintertime, it will add a little bit to your home heating loads, but overall you will still save energy on a year-round basis. Heat pump water heaters also can help dehumidify your home, but they will not replace an existing dehumidifier. You will still need to dehumidify your basement if you have a damp basement. Some households may require a slightly larger water tank than you originally had. Sometimes heat pump water heaters cannot be installed in a confined space. They will require some type of ventilation system if they are installed in a very confined space. Your plumber can tell you whether your existing water heater has adequate ventilation or you would need to add ventilation to accommodate it. Also, there are some differences in the rebates available depending on where you live. If you live in Concord, you can get a rebate on a heat pump water heater in most situations. However, if you live in Carlisle or Lincoln, you must be replacing an existing electric water heater or be installing a heat pump in a new home. So that's a quick summary of heat pump water heaters. Brad, back to you.
Yeah, thanks, Bob, and thanks, John. I hope you have all found this very informative. And pay attention for our further videos, which are testimonials from residents of our towns that have installed these systems in their home already.